Let us move on to page 3 and solve the questions there. So page 3, question 1 says, the length of pregnancy are normally distributed. The mean is 264 days and the standard deviation is 15 days. Well, you are selecting 36 women and then you want to know what is the probability that they have a mean pregnancy between 264 days and 266 days. These are the information that we need to calculate the probability. So let us identify the key information. So page 3, question 1. Well, first of all, it is normally distributed. We're good so far. The mean is equal to 264 days with the standard deviation, which is 15 days. You randomly select 36 women. Okay. You want to know what is the probability? What is the probability that the mean pregnancy, guys, you're using X bar, is between 264 to 266 days. What is this probability? First of all, since you're dealing with X bar, it means that you need to use the central limit theorem. Since you are working with the mean X bar, we use the central limit theorem. The requirement for the central limit theorem is met. Why is that? Because it says the length of pregnancies are normally distributed. Since it is normally distributed, mu sub X bar is equal to the mean of the population, and standard deviation is the standard deviation of the population divided by square root of n. Remember that before finding the probability, we need to know what is the mean, what is the standard deviation. So let us do the calculation. The mean of the sampling distribution of sample means is the same as the mean of the population, which is 264 days. Okay, very good. So far, so good. The standard deviation of sampling distribution of sample means is the standard deviation of population divided by the square root of sample size, which is 36. So what do we get? We get 15 divided by 6. So approximately, let's use our calculator, find this number. We have 15 divided by 6. Approximately, let's say exactly 2.5. Very good. So here we have 2.5 as the standard deviation. Very well. So now how do we find the probability? Now to find the probability, we're going to use normal CDF. Second bars and normal CDF. Okay, normal CDF. So if I go to second bars, normal CDF, what do I see? Second bars norm of CDF. I need my lower limit, I need my upper limit, I need the mean, and I need the standard deviation. Okay, let us identify those. What is the mean? What is the standard deviation? And I will calculate these two here. I'm going to use these two numbers as the mean and standard deviation. But what is the lower limit? What is the upper limit? The lower limit is going to be the same as the lower limit in the length of pregnancies, 264 days. And the upper limit is going to be 266 days, 266. And then the mean is going to be 264 with the standard deviation 2.5. Very good. So here we have 264 and the upper limit 266. Mean is 264 and the standard deviation is 2.5. Very good. So let's do the calculation here. You're going to get 28.81%. So 28.81%.